Hello everyone, my name is Amol Suryamshi. Today we are going to discuss about induction motor. In this topic, we are going to discuss about the construction of induction motors. So let's start. So in induction motor there are main two parts. First part is stator and another part is rotor. The stator means the stationary part of the motor which is not rotating. The stator is a fixed part and another part is rotor. The rotor, it is a rotating part which is not stationary and the load is connected to the rotor of the motor. The figure shows the different parts of AC motor. Here the total induction motor is disassembled and the number of parts are shown in this figure. So the main part is stator and another part is rotor. The stator is placed inside the main body which is called yoke of the machine, and the yoke is made up of cast iron and the function is to protect the all internal part from dust, dirt and other external parameters. Also the fan is connected another side of the rotor and the function of this fan is for the cooling purpose. This fan exhausts the outside air and circulate inside the stator and rotor. So this air dissipate the heat, means this air reduce the temperature which is produced because of the I square R loss. Okay. The construction of stator. The stator is made up of the silicon steel material. Okay. So why silicon steel material is used? This is the main important point. The silicon steel material having very high permeability and low reluctance path. So that's why the silicon steel material is used. So in magnetic material there are two types of losses are there. One is hysteresis loss and another is eddy current loss. So silicon steel material having very less hysteresis loss. That's why to prepare the core of any machine the silicon steel material is mostly preferred. Okay, so this figure shows how stator core is prepared. So by using silicon steel stampings, so and in these silicon steel stampings the slots are provided in internal part. So in that slots the three-phase stator winding is placed equally, means the stator winding is uniformly distributed 360-degree. Okay. And the number of silicon steel stampings are bonded together to form a core. So why silicon steel stampings are used or why laminated cores are used? Because of laminated core we can reduce the eddy current loss, and we know that the eddy current loss is depends on the thickness of that silicon steel material. So if we can use the thin laminations we can reduce the eddy current loss, and to reduce the hysteresis loss we can use silicon steel material. So this figure shows the construction of stator. Here in that stator slots the copper winding is placed uniformly. This is the stator and this stator core is placed inside the yoke or frame. Okay. Here some hinge are provided to that yoke to dissipate the heat which is produced by the stator winding. So this heat is dissipated by radiation mode. Okay. And the three-phase stator winding is uniformly wound in that stator core. Here the three-phase stator winding is wound per phase, and this per phase stator winding is placed in the stator core. So before to insert the stator winding in that stator slots, the plastic films are used. So the purpose of this plastic film is for the safety purpose. So because of that plastic film, the windings or the conductors not damaged. So that's why these plastic films are used. Now construction of rotor. There are two types of rotors are used in induction motor. One is squirrel cage rotor and another is slip ring rotor. The squirrel cage rotor, why it is called squirrel cage rotor? Because the construction of this rotor is like squirrel. Okay. In squirrel cage rotor, the construction of the squirrel cage rotor is the silicon steel stampings on the outer periphery of the stampings, the holes are provided. Okay, and in that holes, the copper or aluminum bars are inserted. So these copper bars act as a winding of the rotor, and these copper or aluminum bars are short circuited by using end rings. So the material of these bars, if copper, then end ring material is also copper. If the material of these bars are aluminum, then material of end rings also aluminum. Here in this figure you can show these bars are not parallel to the shaft, but these bars are parallel from one another. So this made purposefully, because in induction motor there are one effect is known as cogging effect. So what is the meaning of cogging effect? So at the time of starting, if stator poles and rotor poles are equal, then motor cannot start. It is called the cogging effect. So why motor cannot start? Because of the strong magnetic interlocking between stator and rotor. So to reduce this effect, we can make the condition the stator pole is not equal to rotor poles. So by making the copper bars or aluminum bars in squirrel cage rotor is skewed. Skewed means these bars are not parallel to the shaft, but they are parallel from one another. So because of this skewed shape, we can reduce the cogging effect. Okay, so that's why these copper or aluminum bars are not parallel to the shaft. And when these bars are short circuited by using end rings, then this winding, rotor winding, act as a short circuited winding like transformer secondary. And we know that the induction motor is nothing but a rotating transformer. Means in transformer there are also primary winding and secondary winding. Like that in induction motor, the stator winding act as a primary winding and rotor winding act as a secondary winding. This figure also shows the construction of squirrel cage rotor. So these are the bars, okay, and end rings, and in that holes the bars are inserted, and these bars are short circuited from both side to act as a short circuited secondary winding. Now this figure shows the construction of slip ring rotor. Okay, so the main advantage of slip ring rotor is we can add the external resistance in a rotor circuit, because in case of squirrel cage rotor there is no provision to add external resistance in the rotor circuit. So this is the main disadvantage of squirrel cage rotor. So this disadvantage is overcome in slip ring rotor. So how slip ring rotor is constructed? So on the slots of the rotor, the three phase winding is wound on that rotor slot. That's why it is also called the wound rotor. So three phase winding, and this three phase winding is connected in star, and all these three terminals are connected to the slip rings, and the slip rings are mounted on the same shaft of the rotor, and we can add the external resistance to the rotor circuit by using or through the brushes. Okay, so what is the advantage of this slip ring rotor? We can add the external resistance in rotor circuit, and by using this variable resistance we can control the torque of induction motor. This is the equivalent circuit diagram of slip ring rotor. Here the three phase delta connected stator winding is shown in figure, and the star connected rotor winding is wound on the slots of the rotor. Rotor also made of uh, slip ring rotor also made up of by using silicon steel material, and this star connected winding terminals is connected to the slip rings. The slip rings are made by using the hard drawn copper material, or and the brushes is made up of the carbon or graphite brushes. Okay, and these three terminals which is connected to the variable resistance. Okay, and when we vary the external resistance we can control the current of the rotor, and because of this current we can control the torque of slip ring motor. So these two rotors are mostly used in induction motor, squirrel cage rotor, and slip ring rotor. 90 to 95% induction motor is having the squirrel cage rotor, because the advantage of squirrel cage rotor is robust in construction, because there is no slip ring like slip ring rotor. Also there is no brushes, so because of slip ring and brushes there are maintenance is required, and sometimes the because of the wear and tear the reliability of motor will get reduced. So that's why 90 to 95% induction motor is having uh, with squirrel cage rotor, and the motor which is having the squirrel cage rotor it is called squirrel cage motor, and the motor which is having slip ring rotor it is called slip ring motor. So by identifying or by observing the rotor we can directly identify the which type of motor is there. So these are the contents of induction motor. So in this topic we discuss the construction of induction motor, the different parts of induction motor, how stator core is prepared, how stator winding is wound, how rotor is prepared, different types of rotor, that is squirrel cage rotor and slip ring rotor. Okay, thank you.